In this lesson, we are going to focus on three things. First is principle of equivalence. Second is the different types of effective rate of interest, and different types of effective rate of discount as well. And then we'll look at nominal rate. Okay, so we're going to cover these three things in this video. Now let's get started with the principle of equivalence. Before I write the statement, let me ask you a question. Suppose you are given that the annual effective rate of interest is 10% per annum. What will be the half yearly effective rate of interest equivalent to this 10% per annum? So this is the question. Now you can pause the video and think about it for a while. If you have come up with the answer 5% per half year, that is simply dividing the 10% by 2, then I would say you are wrong. Now before I solve this question, let's understand the statement of principle of equivalence first. So the statement is, if two or more rates are equivalent, then their respective accumulation factor and discounting factor for the same time period will be equal. Okay, so in the question you are given 10% per annum, and if you have been following my videos, then you can easily tell the accumulation factor for 1 year will be 1.1 to the power 1, right? Now let x% per half year is the half yearly effective rate of interest. So I can say 1 plus x to the power 1 will be the accumulation factor for 1 half year, right? Now, according to the statement, we can equate accumulation factor and discounting factor when the time period are equal. Here you can see that here the time period is half year, 1 half year, and here the time period is 1 year. So can I write 1 plus x to the power 2? It means the accumulation factor for 2 half years, or in other words, the accumulation factor for 1 year, right? Now we can equate this with 1.1 to the power 1. Now if you solve for x, you'll get 1.1 to the power 1 over 2 minus 1, which is 4.8808%. So as you can see, the half yearly effective rate of interest of 10% per annum is not 5%. This is slightly below 5%. So we cannot simply divide the annual effective rate of interest by 2 to get the half yearly effective rate of interest. Similarly, if the annual effective rate of interest is 12% per annum, then you cannot divide it by 12 to get the monthly effective rate of interest. This does not work this way. Okay, so this is wrong. You cannot do that. Now let's understand a few notations of different types of interest rate. So notations. Whenever you see I2 divided by 2, this means this is half yearly effective rate of interest. So you don't have to write this whole statement. You can simply write this notation, and this will mean half yearly effective rate of interest. Similarly, I12 divided by 12 is monthly effective rate of interest. And if you are given I4 divided by 4, then this is quarterly effective rate of interest. Now here from these examples, one thing you can notice that the number in the denominator means 1 year is divided into this many parts. So here the 2 in the denominator means 1 year is divided into 2 parts. That means each part is 6 months, right? That's why it is called half yearly effective rate of interest. Similarly here 12 means 1 year is divided into 12 parts. That means each part is a month. That's why it is called monthly effective rate of interest. And here 1 year is divided into 4, which means one part is basically a quarter, and that's why it is called the quarterly effective rate of interest. Okay, now this thing in the numerator is nothing but nominal rate of interest. Nominal rate of interest. We are going to discuss this later in this video, but for now let me ask you, what is 1 plus I? So this is accumulation factor for 1 year, right? Similarly, what is 1 plus I 12 divided by 12? So this is accumulation factor for a month. This is the monthly effective rate of interest, and that's why it is accumulation factor for a month. Now what if I give you 1 plus I to the power 4 divided by 4? So this is accumulation factor for a quarter. Okay, now similar to effective rate of interest, we have effective rate of discount as well. That is, whenever you are given d2 divided by 2, that means 1 year is divided into 2 parts, and this is called half yearly effective rate of discount. Rate of discount. Okay, if it is given d12 divided by 12, that means monthly effective rate of discount. All right, and then 1 minus d is the discounting factor for a year, and similarly 1 minus d2 divided by 2 is discounting factor for a half year. Okay, now if you remember, the accumulation factor is the reciprocal of discounting factor. So can I say 1 plus I is equals to 1 minus d to the power minus 1? Now this thing is the discounting factor for a year, but since we have put the minus 1 in the power, that means this has become the accumulation factor for 1 year, and this is also accumulation factor for 1 year in terms of effective rate of interest. So these two can be equated, right? Now similarly, can I write 1 plus I is equals to 1 plus I 2 divided by 2 to the power 2? Now this thing is the accumulation factor for a half year, right? Now if I raise it to the power 2, that means the accumulation factor for 2 half years, or in other words, accumulation factor for 1 year. So this should be equal to 1 plus I, right? Now similarly, I can say 1 I to the power 12 divided by 12 to the power 12. This should be equal, right? And then I can also equate it with the discount rates. So I can say 1 minus d2 divided by 2 to the power minus 2. Okay, so this is the discounting factor for a half year, and if I raise it to the power minus 2, that means the accumulation factor for 1 year. Okay, so in general, can I say 1 plus I is equals to 1 plus I to the power p divided by p to the power p, and this is also equals to 1 minus dp divided by p to the power minus p. Okay, so from here I can write 1 plus ip divided by p to the power p equals to 1 minus dp divided by p minus p. Okay, now one thing you should be very clear about, that is IP, this is in the bracket, this is not equal to I raised to the power P, or for example I2 inside the bracket is not equal to I squared. So this is a squared, but this is not a squared, this is just the notation. Okay, so please keep this in mind, this is not equal. All right, so this is all about the different types of effective rate of interest and effective rate of discount. Now let's learn about the nominal rate of interest. Nominal rate of interest or discount, or nominal rate of discount as well. Okay, now let's understand nominal rate in this way. Suppose a person goes to a bank and asks the bank that what is the interest rate charged on his deposit in the bank account, and suppose the bank says the monthly effective rate of interest is 1% per month charged on his deposit. Now the person as a general consumer always wants to know the annual rate, right, to compare with the other banks, that what percentage is offered by other banks compared to his bank. Okay, so he is always interested in the annual rate. Now what he does is he simply multiply 1% by 12 and he considers this as the annual rate, 12% as the annual rate. But you already saw that this is not accurate, right? You cannot use this 12% in your calculations. This is simply incorrect. You cannot multiply 1% by 12 and consider this as the annual rate. Okay, annual effective rate of interest. This is wrong, right? But you all at the same time you cannot expect this level of knowledge from the general consumer. Okay, so for the general consumer it is always convenient, to multiply by 12 and and get the annual rate 12%. So the nominal rate of interest is actually for the convenience of general consumer. Nominal rate of interest is useless for calculations. We do not use nominal rate of interest in our calculations. We always convert nominal rate of interest into effective rate of interest or effective rate of discount for our calculations. So it is always useful for the general consumer. For example, if the quarterly rate of interest is let's say 4%, they simply multiply it by 4 and this is 16%, and they consider this as the annual rate. Okay, because there are 4 quarters in 1 year, so they multiply it by 4. But this is incorrect. We cannot do it in calculations. The effective rate of interest also comes around this value, so it's only for the general consumer. Nominal rates are useless. Also nominal rates are annualized rates. Now what I mean by this is, you always see in the question written something like this: 12% per annum convertible monthly. Now this means this rate can easily be converted in the monthly effective rate of interest by simply dividing it by 12. So 1% per annum is the annual effective rate of interest. So this is useful. This rate we can use in our calculations, but we cannot use this rate. And here you can see this is per annum. That's why I called it as annualized rate. So this is forcefully made annualized. Okay, and you always see wordings like convertible or compounded, or you may see 12% per annum nominal rate convertible monthly. Okay, so these are few wordings that are often used for the nominal rates. Okay, suppose you are given 10% per annum convertible quarterly. So this means the quarterly effective rate of interest would be 10% divided by 4. Okay, So this will be the quarterly effective rate of interest. So this is how you can convert the nominal rate into effective rate of interest, and then again you can change that into effective rate of discount using the relationship between accumulation factor and discounting factor. All right, so this is all about the principle of equivalence, different types of effective rate of interest and effective rate of discount, and nominal rates. So now let's stop here, and I'll see you in the next video. Thank you so much for watching this video.